Okay. So when you get to number 7 on your practice district assessment, because I'm recording, you need to know where the vertex is. And so when we talk about restricting the domain, the first thing, and I'm just going to not make this take too long, is that on number 7, both of the graphs are parabolas. So you might have forgotten this, but anything that has x squared, whether it's x plus something squared or x minus something squared, by definition, anything that is y equals x squared is a parabola. It's called a quadratic function. So all of the graphs on number 7, they look like this, or they look like this. We agree? So the idea is I need to go snippy, snippy right at the center of the graph and essentially chop half of it off, restricting the domain so that when the graph falls over and becomes an inverse, that it too will be a function. Because if there's this thing called the horizontal line test. So, like, if I give this the horizontal line test right now, I can predict that its inverse will not be a function because it won't pass then the vertical line test, right? So, what I'm trying to say in my typical long-winded way is we really need to know this point. What's that point called again? The vertex. And so we're going to go back to something that I don't know what you said, but it was almost as bad as those curly brackets over there. So we're going to, we're, we're going to remember how to find the vertex. And so very specifically now, let's get into it. On problem number 7, you have a function written, and again, I'll give you more practice for this. I'm kind of stealing your opportunity by doing this with you, but I'll give you more. So we have x plus 4 squared minus 3. I sure hope they'll hear the Minecraft music in the recording. I think it only picks up the ambient noise from my microphone. Guess we'll find out. So, can you guys tell me by chance where the vertex of this parabola would be? Just from looking at it's a point.
-3, 0.
Well, Brady's guess was the closest, but the answer is -4, -3. So what we would have talked about a long time ago when we first learned this is that to find the vertex of a parabola, if it's written in this form, which by the way is quite literally called vertex form, we learned that the argument of the function, like the x minus 2 or x plus 5, that part of it squared can give us the location of the vertex's x coordinate. And then the back part is the uppy downy part of the vertex. So notice how I'm not having like a stroke here. Notice how I took the opposite of +4 because I'm trying to effectively center out that argument. I think to myself, what squared, how can I force that squarey part to be 0? And that's where the -4 comes from. The -3 is just a vertical shift. So there's no tomfoolery with that. So let's practice that skill again before we talk about what to do next. So let me give you another quadratic in vertex form, and you guys tell me where the vertex would be. Where would the vertex be?
+5,
+5, +6. You okay? Okay. So the reason we care is because if we know where the vertex is, then we know horizontally on the x-axis where, if we looked up or down, we would see the vertex of the graph. And that's the magic point at which we want to go snip, snip on the half the graph gets thrown away, half of the graph gets kept. So as a general rule, we keep the positive side of it. And so take, for example, the one that's on your paper. If we know that the vertex, which I erased, is at -4, -3, I'll just sketch this real quick just so you can have a little bit of buy-in. So -4, -3 would be a point that would be left 4 and down 3. So I'll just stick it like right there. So we know we have some parabola that forms from that point, right? So we want to restrict the domain from this point. And by the way, the parabola probably looks something like this, okay? So what we want to do is cut half of it off. And so how would we restrict the domain?
Don't use any points that are less than -4.
I like it when you guys just use plain flippant English to get a point across. Yes. Don't use any x's that are less than -4, I believe is what you said. Yes. So now we need, since it's math class, to come up with a really fancy way to write that. And you might remember that the way we restrict a domain is we say we want to just keep, so we say the domain is the set of all x's such that x is greater than or equal to -4, like that. That is our domain restriction. That's our way of saying basically what Cooper said, and that is that we just want to keep the x's that are at or to the right of the vertex. What we effectively do when we restrict a domain. Is everybody okay?
No, I heard it. Really bad ones.
What do you know what paint tastes like?
So that is how we're going to go about restricting the domain, is we are going to find the vertex and then snip the graph to the left side of the vertex, keeping the right side. Got it? So the moral of the story there is, if I can't find the vertex, I certainly don't know where to restrict the domain, right? And if you say you forgot that and Wednesday or after break comes and we're taking our district assessment and we forget and we're like, I don't remember how to find the vertex, there's nothing stopping you from making a good old-fashioned table of values and actually sketching the graph to find the vertex, going old school like 1980s mode. Okay. But being able to find the vertex quickly is the key. All right, let's take a look at problem number 7, part A. The trick here is that this is not written in vertex form, but I still need to know where the vertex is. So do any of you, and again, I'm never offended when you can't answer these questions, but from a long time ago, do any of you remember how to find the vertex of a quadratic when it's written in this format? Yeah.
Change it back to vertex one.
You can if you want to. That's very ambitious, and that's honestly not an unattractive option at all. I'm just going to go with another one real quick, just because it's a little bit closer. But I love what you just said. Do you know how to change it back to vertex form? Completing the square. YouTube. Just stop. Stop this all. Okay. Go to YouTube right there. Stop. Just focus.
Reverse.
I think you're thinking of what Blair said, and that is you want to turn it back into vertex form. I'm going to show you that in a second. I did not even see that coming. I did not have that on my bingo card, but I'm going to go over that after I show you the other way. So there's a formula that I gave you before, and it says that for any quadratic like this that's written in standard form, the vertex can always be found at -b/2a. And again, I'm not hurt if you don't remember that, but that little handy dandy formula gives us the xe location of a vertex. And really, if you think about it with domain restriction, that's actually all we need is just the X location. So in a case like this, while what you're saying is really awesome, and I totally want to get on board and do it, this will just be a lot quicker in a case like this. So if I want to know where the vertex is, I just need to know who A, B are. And A is, of course, just like it always has been, the number in front of X squared. What's B? Right, and C is 4, but we're not doing the quadratic formula, so no one really cares. All I need are A and B to find the vertex. So I plug them into this handy dandy little formula over here, which is the opposite of B divided by 2A. So what's the opposite of B? And what's 2 times A? And what's 2 divided by 2? So here's the upshot. This is what it means. It means that there is a vertex at 1.
Really good question.
Something. Do you understand? But if this were a lesson where I said to you, let's go graph the parabola, let's go get her done, then we would need to go and actually find more information about the vertex. But if you're paying attention, you understand that I actually don't give 2 rips about the y coordinate of the vertex. I just want to know his x coordinate, right? Because that's where I go snip on the domain. So at this point, I'm actually done, and I can just say that the domain needs to consist of all x's such that x is what?
Greater than.
Right.
I don't know, maybe greater than question.
You just do. I know that's a really unprofessional answer. Because on the other end of things, when we're coming back the other way and we square root, we take the positive negative, but we always keep the principal square root, which is the positive. So that's a really bad answer, but just keep the positive side. For now. That work?
That's an ugly curve.
Oh, it is not.
Left one?
Don't, you're gonna hurt his feelings.
Yeah, you hurt my feelings.
Hey, if, well, those were pretty bad. It's not my finest work. I'll put it that way. But it's not like Bryn quality. Listen, I got 19 levels of curly bracketology below me before I hit Brinley status. So I've got some wiggle room here. I'm sorry, Bryn.
I noticed this before. Your
Besides,
left ones always look like that, and then your right ones again.
So my left ones are ghetto is what you're saying. Okay, I'll work on that. Duly noted. Do you want to see the other way to do it?
No, this is fine.
Are you sure? Okay, because I could show you how to turn it back into vertex form, but if you've moved on from it, then we're okay.
When we find the inverses, just the exact same, you just switch X and Y.
Yeah, so exactly the same as what was on your quiz. In fact, a lot of this practice district assessment, I just copied and pasted over and then changed some things from the quiz. So a big lion's share of this quiz is actually, or this district assessment is going to come off of that last quiz. And I've opted not to give you a second quiz. That's why I say I just wanted to dive in. Let's get this district assessment done as quick as possible. Because there could have been a whole nother quiz for a few of the problems and decided, nah, let's just go. Let's get out of this. Yes, so the domain restriction, oh, except it also says then to find the inverse. So after this, then we have to go and find the inverse. Yeah, so the original function is y equals, and I didn't do this on the other one, I apologize. The original function is y equals x squared minus 2x plus 4. So then we're going to do our inverse thing. So we're going to switch the variables. So we're going to get x equals y squared minus 2y plus 4. And we do have to yeah, we can't get away from it. So the thing that I thought we were going to be able to dodge, we can't dodge. So you ready? Okay. So do you guys remember completing the square? Let me show you something. I don't know why you just randomly shouted that at me, but that was, I'm just going to move on. I'm going to show you guys something. Are you ready? We're going to move this off to the side like this. Okay, everybody good? Okay, and now we're going to complete the square. Can you guys think of what could go in this little blank right here?
Plus.
What if I told you, I'll just tell you right now that it's a +1. Would you think I was crazy? Well, factor down the white box for me. What do you get?
Y minus 1.
Y minus 1 times y minus 1, which is y minus 1 squared. Did you get that? Did you see it? Okay. Now, do you see how I added a red +1? To make that go away, I have to turn around and I have to subtract 1. We did this in Algebra 2 when we were converting standard form into vertex form, which I kind of forgot we had to do that on this problem. It was my bad.
Like the reverse.
Yeah, effectively. Yeah. So what we're going to do now is we're going to take everything from the white box became this red box. So let's talk about that first. What is the net result of these two numbers that I'm underlining? What's 4 minus 1? 3. So what we have right now is this. Got it? And now we need to resolve for y. And I'm actually going to answer Brady's question here in a second, which I didn't really think I was going to get a chance to, because I really half-hearted that first answer. But now you get the better version of that explanation. So what do we have to do now to solve for y? We have to move the 3. Very good. So now we have y minus 1 squared equals x minus 3. And then what's the next thing we have to do to solve for y? Good job. So this is the part where I'm going to try to answer Brady's question. And I've honestly avoided this question to whatever extent I've been able to up to this point. But at this point in time, the answer would look like this. like that. But in mathematics like this, when we take a square root and we're like functionally working like this to keep things having inverses, to keep things passing vertical line tests, we do not incorporate both the positive and the negative. So that's why I say if we're going to keep the positive on this one, which is what we do, then we should keep the positive on the other one. Is that any better of a version than my last explanation?
Yeah,
Good. So what we can now say is that y equals the square root of x minus 3 plus 1. And then the only thing I'd get dinged for on a test would be not using proper inverse notation. Someone in this room knows a little something about that. You know who you are. So we would, in this case, since we're on problem B, we would say that G inverse of x is equal to the square root of x minus 3 plus 1. Got it? And that is the inverse of the original problem. And the reason is because we restricted the domain of the first one so that it would only be a halvesies. Not the full parabola. It would just be a para or a bola. You choose. Would you like to practice that again? What?
that's fun.
That's not good.
Yeah.
But I'm safe. I am. Do you guys want to practice that again? That was a lot to digest. I'm not going to. Because I'm in a safe place. They can't see me. I'm behind glass. It's okay.
John Cena.
I don't know what you just did there. Was it one of these things?
You can't see me.
Is that it? Oh, that's. Oh, I do know. Yeah. Okay. You want to practice? Someone said they wanted to practice that again. You want to go again? All right. Let me give you a new function. We'll call it m of x. And it'll be like x squared plus 8x minus 10. So pretend that this is problem number 7, part B, and let's try this again. So our job, first off, is to restrict the domain, and then we're going to find his inverse, and we'll be good.
With it. Placement for negative penalties. Yeah, 4.
Negative 4 is correct. Good job. So thank you for learning what I tried to teach you a moment ago. And that is that the x coordinate of your vertex will always be located at negative b divided by 2a. That's good to know. That's just part of the quadratic formula without all the plus or minus the square root part. So that's where the centering out happens right there. And in this case, b is negative 8, or b is positive 8, and a is positive 1. So negative b over 2a is negative 4. So again, the vertex is at negative 4 something. We don't care about the something. So what would our domain restriction be?
Going back to x. But a straight
That
line,
vertical line it replaces the word such that. So the set of all x's such that.
x is greater than.
Nice job. Okay, so domain restriction complete. Any issues with that? Yeah, that's kind of goes back to Brady's question. We just keep snipping off the left and keeping the positive side, the right
So you
side.
don't have to, like, do the mental math of finding the replacement. It's
The mental math of figuring out what the y coordinate would be.
not like completing the.
We have to do that now. No, we're done with the first half of the problem. Do you see how it says restrict the domain? Okay, we're done. But now you see how the second part says find the inverse? Now we have to go do that. That's what we haven't done. So that's the last part of this, is to take the equation. So the problem that I wrote you was y equals x squared plus 8x minus 10. And so what do we have to do now?
X equal
Yeah, let's swap them first. So x equals y squared plus 8y minus 10. And then this is where it gets a little bit interesting from here. So who remembers the next step? Yeah, so I like to just kind of take the 10, the minus 10, and move it off to the side. And then I'm going to complete the square. And does anyone know the magic for what number goes in this blank? Did you figure it out? You knew this at one point in
Divide
time.
the middle one.
Yes, you divide the middle one by 2 and then do what?
12%.
60.
16 is our guy. Yes, and so you'll remember that the pattern for this is to take the middle number divided by 2 and square it, and that would mean that adding 16 officially completes the square. And then we turn around and subtract 16 to make sure that there was no evidence that we were ever here. Good. Got it? Are you okay? By adding 16 and subtracting 16, it's like we were never here. So you take this number 8 and take half of it, which is 4, and then you square it, and that will always complete a square. That will always make a what we call a square trinomial. Okay, so give me a couple more minutes and then I'll get you out of here on time. Okay, so let's wrap this up. So what replaces all of this right here? Five plus 4 squared Nice. minus 26. Okay, let's finish this off. What's the next thing we do? We add 26, so we now have x plus 26 equals y plus 4 squared. Next step, square root. And remember, like I tried to show you last time, but I don't think it went all that well, is just take the principal square root. So we're going to just say that y plus 4 is equal to the square root of x plus 26, like this. And then what's the final step? Subtracting 4. So we can finally now say that like f inverse of x is equal to the square root of x plus 26 minus 4. Oh, it's m. You're right, it was. I thought I could like not look back up, and well, that's what I get. So that's that. So tomorrow, I don't think we'll be ready for this assessment on Wednesday. So we'll just keep hammering through. We'll work today, tomorrow, we'll work Wednesday, probably take Thursday off, and then we'll focus back on this after the break. I think so, yeah. Is that, you want to?